Hi. Motion tracking is more complex than I thought. I was wondering why everyone is not doing it. But don't you worry, I am the rare holder of the ancient secret of solving any complex problem. Let's break it down into a smaller chunk. Today we will cover the arm movement, how to review the motion lines, to understand your animation with a graph, and how to transform the video into the skeletons that can be used with Adobe Character Animator. First, we need to record the video. We are exploring the arm behavior, so we need to make sure that elbow rotation, shoulder rotation are covered in full. Additionally, we need to record the areas where the wrist will be in the inside zone. You can reference this graph to understand what those zones are, but there are also some pieces that cannot be covered with the rotation alone, so we will need to implement some scaling too. So let's start one by one. We record the video and cover all the range of movement. After this, we'll need to get the joint from the video. For that, we will use the media pipe project from Google. It will allow us just crunch through the video and save all joints to the file with minimal adjustments. Now, when we save the coordinates of our joints, we can use some math and geometry to figure out the angles of the joints. My original idea was to use the triangles and calculate the angle to figure out what the MIDI signal to send, but it went a little bit too complicated, so I think I found a better way. Imagine that we are looking at a map, not on a screen, and the north will be up, the south will be down. Now, we take the shoulder joint and draw the line towards the elbow. This way, we essentially have the compass that represent our shoulder rotation. And it will have value from 0 to 360 because it's a full circle for the compass. And this can describe what our shoulder is doing. Last thing that we need to do is scale our value to 0 to 127 range because we're working with MIDI, so MIDI understands 0 to 127. So 0 will be 0%, 360 will be 100%, or 127 in MIDI range. The elbow will work in the same way as the shoulder. We just take the elbow dot and draw the line towards the wrist and follow the same logic as north and south on a map. We can go over the full video and record all values for the elbow and shoulder rotation and replace them later on. Let's see how it looks when we put the value for our elbow and shoulder on a graph so we can look at them over time. It is important to understand how to work with this graph if you want to work with animation using this method, because it allows us to eyeball a lot and kind of understand where our movement goes and find some bugs. The main purpose here is that it's very easy to look for mistakes and understand the movement patterns. The final graph is very busy, so let's add things one by one. First graph represents the elbow MIDI signal that we'll send to Character Animator, so values are from 0 to 127. We can see what are the values in the different points of time for our elbow rotation, and we can understand when our arm enters the different zones for the elbow flip as well. It's useful to note for the future because we will send essentially a button that will flip our arm when we enter the different zones, so we actually flip our forearm and wrist among the axes. We can also see a duration of our movement on a graph. If we see the steeper line, this means that the movement is fast. If we see the arc shape, this means that arm goes back and forth. And we can kind of understand where things are going, and if we see some dips that we did not expect, we can address them or at least find them very easily. Note that the graph goes from left to right, but the arm moves in a circle because it's a rotation. So there are moments where the line goes from the max to min instantly. This is not a mistake or doesn't mean that our arm have some jerky movements. It just means that we set our rotation knob from 100% to 0%, and because it's a rotation, the whole process should be smooth. From this point, we understand the main idea of the graph and how do we look at the data points. So we can add more. Shoulder and elbow are very similar, plus it's easy to detect when our arm is straight. If we look on the graph, we can see that the both line goes together when our arm is straight. So it's nice because they have the same orientation. Something more interesting would be the arm scaling. We can see that when we move the wrist closer to the middle, it essentially shrinks how much forearm we can see. We can calculate this distance and use this to scale the elbow for our character. We can see the distance for the elbow and for the shoulder on the top of the screen, and the values are here from 0 to 127 as well because we are using the MIDI. But scaling has its limits. As we are approaching the center zone for the wrist, at some point we will need to flip it because our arm now gonna point forward. We call it a center zone. We will keep track of the distance value and send the button to activate the different arm flip in a character animator, so this is fairly easy to understand. And as we are putting it on a graph, you can see that we will just use this line to trigger it from 0 to 127 to just understand when our arm is inside. Note that in this case, we are using essentially a button press, so we don't have to track it and press it all the time because the arm will flicker. We just send it one time when things are changing. So when we enter or exit the center wrist zone. This is not the only buttons that we'll have to press essentially, because we also need to flip our wrist and forearm based on the zones. See this diagram. Here, it's a little bit tougher to figure out specific buttons because we need to react on 4 different zones as opposed to just on and off, but general logic is exactly the same as for central wrist. We just look at the MIDI values and we can just rig it in a character animator and just set up the arm to point down, which would represent all zeros for our recognition software. And we can just move it around and understand where our wrist enters the different zones. We can also refer to the graph and just to figure out, hey, what do we need to do, where we need to put our values to flip different wrists. The easiest way is to kind of play around with that at this moment. We'll see if we can make the process more reliable. The last thing that we need to calculate is the distance between the shoulder dot and the elbow. This works pretty much the same as scaling for the forearm, but it allows us to do the hit animation. We will use the scaling controller to increase the size of the front wrist and give the impression that the arm is getting closer to the camera as the character is hitting. We can see that the final movement recognition does not follow the arm exactly, and in this case it's on purpose as we are smoothing the movement to avoid these jerky parts. But in the future we will see if we can improve the accuracy of our recognition because we want to work with dances as well and they are more timing critical. Maybe we will sacrifice some smoothness of the movement and we can make it better this way. It's not supposed to affect non-dancing performance capture though because it's pretty close. All that allow us to see the state of the arm and give us some ideas on how to edit it and how to work with this in the future. For example, I do like the graph, but it's not too comfortable to work with at the moment, plus adding and removing elements is quite clunky, so I want to have something where I can do it on the fly, just add or remove elements, or even look at the motion line, and if I see some dips, maybe just click around or smooth out the line or make it, more sharp to be able to adjust animation on the fly and without doing anything fancy with that. So we will keep developing it in this direction because I do like it. I'm not stopping to review the code too much because I assume that more people gonna be interested in running it. So I will keep this as of now. But if you have some technical questions or want me to get some deeper dive into IT side of things, let me know. In the future, I will add more functionality to the motion recognition, and we will work on a player for the character animator as well to actually replace this value and record the performance out of it. It took quite longer than I expected to figure out how to track joints and angles reliably, and we will keep throwing the different videos to make it even more reliable in the future. ZQ whistle zskwak kyu nci oyr pa. Encoding error. Cheers.